Like, I have no idea how to sponsor these guys. I'm like, yeah, okay.
Yeah,
But yeah,
but you
so I
made it.
sat for the
But you
test. It
made
was
it. How did you
fine.
find the test? Was the stuff we covered relevant?
Yeah, it was dead on, spot on. I mean,
All right, good.
I didn't get to work with you on that last class where you went over the question per se,
Right, right, right.
but everything was spot on, very helpful. And
Good.
I don't know what the grade was. They don't tell you that. They just tell you you passed.
Yeah, yeah, that's okay. That's all you need to know is to pass. That's all. Nobody keeps track of the score, so that's fine.
I'm just curious.
Yeah,
So I
yeah,
took your advice. I sat for the general right afterwards.
right.
And he basically said, "Okay, you're a tech. Have a good night." So I tried.
That's fine. That's fine. That's fine. So, so you made out okay, and you had no problem with any of the questions or anything.
No, not at all. Not at
All
all. There
right.
wasn't one thing that you hadn't covered. I mean, it was all
That's good.
there.
Good, 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 good.
No
I love
complaint.
that I love that feedback because that just keeps me honest for the next class. So I just want to make
You're a
sure.
saint. You're a saint.
Tell that to my wife. Okay. That's,
But listen, let me dig into you. I wanted to ask you. I emailed you. You said to hold on. I
yeah.
wanted to.
So yeah, they're
Go ahead.
both excellent radios. You're talking about the ICOM versus the Yaesu,
Yeah.
right? Yeah, they're both excellent radios. For that kind of money, I don't know what your budget is. I mean, I own the 7000. I bought it a number of years ago, and I'm very pleased with it. And I've had no issue with it, and I like it. But it's obsolete. It's no longer made. The
Right.
7100 is fine too. Take a look at the new Yaesu. The new Yaesu has the antenna tuner built in and all of that stuff, and I think it's about $1,300. I believe it's the Yaesu 997.
Okay.
And take a look at that. Just consider it. But they're all of those radios you mentioned. They're excellent. So, but the new Yaesu has the antenna tuner built in, and it has a touch display, and it's just a beautiful, beautiful unit. I think it's around $1,300 if you're willing to spend that much. If not, the 897 is awesome also. The only thing 7000 it has a really good computer interface. So, and so does the 7100. So
Right.
you can hook it up to your computer, and it goes right away. I mean, there's no special.
Well, with the Yasu there is, you're saying?
Well, with the 897, because that's an older unit too, I think that was
Right.
phased out. Not that it's a bad unit. It's a very, very good radio. It's an excellent, excellent radio. So, but, it's like anything else. With, a couple of years, the technology makes a big difference. It's up to you. It's up to you. They're all super excellent radios. So,
Well, I'm gonna be honest. What was tamping on and everything? I was looking at eBay, even used the 7000.
yeah.
You're
Yeah.
looking at 1200.
Yeah,
So that's no warranty. God knows what's really been done to it. If
yeah,
you go to the next model up, which is now the 7100, you're looking at 1799.
yeah,
Then you're still looking at a tuner and the whole antenna, which was the next question I had, because I'm still lost on this bazooka concept. But anyway,
okay.
putting all that together, no, I don't
Yeah,
have $3,000 to
yeah,
put
yeah,
into
that's
this
a lot
at
of
this
money.
point in time.
Hmm.
So that's why I was looking at the ASU, other people talking about it, other videos. Now that's, you could buy used 600. I'd rather get the new for the warranty. It's 1,000. If I
Yeah,
can, take
yeah,
a dipole and turn it into what I thought was a bazooka, wrap that around the PVC pipe. With a $100 tuner, that's more reasonable and affordable. That's within my reach.
So generally, just as a generalization, issues they're much more sensitive receiving than the ICOM. Not, they're significantly receive better, okay? The ICOMs push better. They transmit a little bit better. I'm talking about a little bit. I'm not talking about, tons of stuff. So I own a Yaesu, a little Yaesu, and I own an ICOM, and that's been my findings over the years. But they're both excellent. They're excellent choices. I mean, they're world-class radios. So, you know, I can't. You know, it's like if you said, should I buy it? Oh, somebody got me on that one. If somebody said to me, should I Ford? You know, hey, no, there are Ford people, there's Chevy people. I need somebody to mute the phone. All right, hold on. Of course, whoever that is hasn't dialed in yet. Waiting for name. Okay. Hiya. So my suggestion is either of those radios, any one of the ones you mentioned are fantastic, and they'll last you a lifetime. So
now I want to thank you for that. I'm definitely going to run with that. But what I have to also ask you is I'm really still confused on the antenna.
Okay, I can review that with you. So basically, all you do is let me see if I can get this this pen working. And if I can get the pen working, I'll draw you a diagram here. Hey, I almost got a pen. All right, hold on. Let me
no, you take your time. Thank you.
Hold on. Let me. It's not letting me.
You guys hear me?
Yep, can.
Oh, fantastic.
No
How are
problem.
you guys?
Good. How are you?
All right. Looking forward to this.
All right.
I've been taking online tests. I think I'm averaging between 30 and 33.
That's awesome. So what are you doing in this class? You got it down pat. You're gonna be doing awesome. That's great. That's great.
That's what we're looking for.
Yeah, that's awesome. Yeah, it's very close to the tech class. All right, hold on. I found my pen. I'm in the middle of answering a question here. Hold on one second. Okay, so what you do for the bazooka antenna, it's really very simple, right? So what you're going to do is you're going to get a piece of PVC pipe, okay?
Right.
And I'd say a 3-inch pipe or a 4-inch pipe if you can find it. Home Depot, I know, has this. They use them for sewers and stuff.
Okay.
But you only, depending on the size antenna that you're going to need, you know, for where you want to go, I wouldn't get too crazy. So what I would do is I'd go maybe for a 40-meter antenna. So we know that 40 meter is how long? I forget.
I got to look back at that.
120, Joe.
120, okay. About 120 feet, okay? So it's about 120 feet, right? So I would get like a 5-foot section of antenna, okay? Should be fine. And then just go to Radio Shack if they're still in business where you are, okay?
Yeah.
And what I would do is just take the wire, right? And then you're just going to one side of the wire. You know, it could be speaker wire, whatever's cheapest kind of wire. Yeah. And just wrap it on this side and take another piece of wire and wrap it this side, right? So it's going to be 60 feet of wire here and wire here. Ooh, somebody's hurting me. Okay. Anyway, and that's it. And then you're going to end up in the wire. You're going to need a little block to turn it into. I'll show you one next class. They make this. You can buy them for about $4 on Amazon, and it turns it into a BNC here. And then you plug your radio. Here's your radio, and you plug your BNC cable into here. That's it. And this is functionally a dipole. So you can put it near a window, just near the window, and you'll be impressed how well it does. So if this is too big, you can go for a 3-foot. You know, just be careful with the windings, right? Nice and tight windings around here, and you have to experiment. I'll try to find the article on it. I've just been so busy at work, I haven't had a chance.
No problem. Thank you.
But yeah, no problem. And this works absolutely well. This is for full wave, okay? You could actually go half wave, 40 meter, and you know do so half wave, half-wave antenna, do 60 feet, and then you only have to wind 30 feet on each side. But I haven't tried this half-wave. I did build a 40-wave, 40-meter, and man, oh man, that surprised me. That worked really, really well. So I just put it near the window, and off you go.
You're not worried about RF with this?
Again, I don't want you. Depends how much wattage you're going to put out. Number one. So for me, it's not a problem because the most I ever put out on a really bad day is I put out 10 watts. Maximum I put out. Because it's no fun for me to do it at 100 watts. If you're going to do 100 watts, you know, I don't want you to be on there all day transmitting. Receiving, knock yourself out. But transmitting, you know, I want you to be careful. I don't want you to get hurt here. So, again, it depends which window you put on. If you make this wire long enough, you can put this in another room, you know.
Outside on the terrace, so it's actually outside.
Perfect. Perfect. Yeah. Knock yourself out. Knock yourself out.
All right, lastly with this, you're still going to need, we're definitely going to need the tuner though, right?
Yeah, so absolutely you're going to need a tuner. Yeah, you're going to absolutely need a tuner.
And this will carry old bands?
Yeah, with a tuner, you can make it multi-band. It'll be good up to about 80 meters. You'll never make 160 meters on that, but you'll do 40, and then you'll do 20. You can do 10. You can do 17. They'll all work because of this. So
okay, there'll be no problem
if you use this formula, right? If you use this formula.
Correct.
How high up are you?
19th floor.
No problem. No problem.
Yeah, I'm right across the street from First Precinct. I'm downtown.
Oh, so you're by Ground Zero.
Yeah, I'm right there. I'm down the block.
Yeah, I know exactly where you are. Okay. So, yeah, no problem. Actually, that's not a bad place for you to work. There's a lot of buildings, but the signals bounce all over the place, and you should have no problem with this. And you can even go with, and if that doesn't work, an even simpler antenna is a quarter wave 20-meter antenna, which is just, so 20 meters, right, would be 60 feet, and a quarter of that would be 15 feet. You can actually just hang it out your window, and that'll work fine. You can build a little dipole.
I got neighbors here. They see something banging into their window, guy. You know what I mean?
That's true. That's true. You'll freak everybody out. Yeah, you're right.
Wankers.
Yeah.
My last question.
Yeah. So you're at about. You're about 152 feet up high. Yeah, that's pretty good. That's going to work fine. Yeah.
Okay, lastly, pertaining to your original, the 40-meter, because like I definitely have the room on the terrace. I don't feel that'd be an issue. I wouldn't have a problem also utilizing what I have now, the 2-meter and 70 centimeter.
Yeah, you'll do great. Are you kidding?
Okay.
You'll do awesome. Just go out on your terrace and hit the button. You'll do fine.
All right, cool. I really appreciate that.
Yeah, no problem. And the New York City clubs, they're awesome. They'll hang out with you. They're great people. Okay, good evening, everybody. How's everybody doing?
Good evening, Joe.
Doing great,
Joe. Hello, Joe. Just great.
Did anybody else take the exams yet? No. We had one guy. He passed, absolutely passed, which was great. He did well. I think he aced it.
For Saturday.
Hey, Joe?
All right. Yes, sir.
Yeah, Richie in the Bronx. I took it Thursday and passed it.
Awesome. So how did we do in class? Was it all relevant to your passing?
Yes, it was, and half the general questions were what you had already gone over also. But I went down in flames on the general also. But I got 20 out of it, so I'm not far off.
Yeah, that's fine. That's fine. That's fine. No worries. The reason that I tell you not to worry, and I suggest that you take the general, is because the questions, I want you to get used to it. I want you not to worry, stress about it, and you'll see how easy it is. It's really very, very simple. So compared to all the stuff you had to study, this is a piece of cake. So anyway, let's get started. Unless there's any other questions that I need to answer. Everybody good? All right. So what I want you to do, I don't know how many of you got the general manual or how many of you are missing the general manual. I certainly suggest that you get it just for reference moving forward. But if you're missing the general manual, the only chapter I'm going to send you is I'm going to send you 2 chapters if you need them. I'll send them to you anyway, whether you need them or not. And they are Chapter 4, which has the math, and I don't want you to freak out about the math, and Chapter 5. That's the only ones I'm really interested in that we really haven't covered. So I'll send those to you, and I'm also going to, at the end of the class, we're going to talk about a couple of little math things. The manual makes it much, much harder than it has to be. I'll show you how easy it really is in Chapter 4. So even if you haven't looked at Chapter 4 yet, bear with me. We're going to cover the math tonight, and then you can put it in practice on it from now until Thursday. So we normally have the same number of classes for the general class that we do for the technician, but I'm going on vacation, so we're going to give you the Reader's Digest version. And what I'm going to focus on is you passing the exam. So, and then of course the exposure thing and some safety things, right? So I strongly suggest to you that you go over the exams over and over again on hamstudy.org to get familiar with it. If you get stuck with something, certainly bring it to my attention, and I'll review it with you so you understand what's going on. Okay? All right. So what I want you to have here all the time at every class is the study sheet that I sent you. I'll send it to you again. Okay? So just so everybody has it, this is going to be, I guarantee you that all of these things are going to be on one of the exams, at least one of the exams. So I need you to know these things, okay? So I'm starting here on page 1. Everybody can see my screen, right? We're good? All right. Richard says, Chapter 4 is a beast. Okay. All right, I'm going to answer some of these texts that I just saw. Anthony said, hello, and Anthony said, which Yesu, whichever Yesu you like. Robert said, happy St. Patrick's Day. Forgive me, have happy St. Patrick's Day to everybody. Richard Lee says, Chapter 4 is a beast. Nah, it's a piece of cake. They just make it sound that way, okay? So don't worry. Okay, so what I need you to know here is this last item here on these frequencies. These are going to be your new privileges. Notice it says that the bolded items are on the pool, okay? Which means, which ones I need you to know is I need you to know this 10-meter one here. I need you to know the 12-meter one. I need you to know these frequencies here. And I need you to know these frequencies here. So all the ones that are bolded, I want you to know, okay? The reason that you need to know this is your guys are going to go on HF. You're going to be mixing with people with extras. Some of the people take this seriously, and they'll get really pissed off at you if you have a contact with them and you're not authorized to be on that frequency. They get really upset with you. So it's important that you know where you can't and can't go, okay? So that's the reason we want you, okay? And you get, even if I've done it by accident, you know, when I was a general, I went on to frequencies that belonged to extras, and they got all sorts of, you know, bent out of shape. You know, I'm trying to tell them, take a pill, you know, relax. This isn't the end of the world. But they got very upset. So this is pure memorization, okay? Nothing I can do about this to make your life easier. You're just going to have to know it, okay? So try to practice remembering this, okay? All right. As generals, okay, this is the power that you're allowed, 1,500 watt power, okay? Peak envelope power is a term we're going to discuss during this. And basically all it means is, let's see, I got to switch to my new drawing tool here. Hold on. So if we look at, come on, get over there. All right. So if we look at a wave, this isn't working. All right, let's try it here. I hope you guys can see it here in the corner. So if we have a wave, okay, so what it means is this volume here and this volume here, that it should be equal, although my drawing doesn't look that way, okay? So this is the peak power at which your carrier will go, okay? That's called peak envelope power. That's the layperson's definition of that, okay? Is it exactly correct? No, but that's what I need you to know for right now, okay? Then the next thing that we need to talk about is RTTY. Everybody give you a demonstration in a technical class for RTTY, okay? And what we need you to know is where is RTTY, okay? Occurs on 80 meter, on 20 meter, and on 20 meter reading and 20 meter PS401K. What frequencies do you start at? You do have these privileges as generals, okay, to play with RTTY. So if you go and you're going to do RTTY, a digital mode, this is where you're allowed to be, these places here. I'm trying to highlight this and it's not working, and I don't know why. I do know why. Oh, man. Okay, so I want you to know that these guys are there. They're going to ask you that, okay? And then they talk about symbol rates, okay, for packet, RTTY, or any data modes, and you're going to need to know, excuse me, you're going to need to know these things too, okay? Again, I'm giving you the Reader's Digest version. I'm going through this real quickly, and then we're going to go through the manual really quickly, except for chapters 4 and 5, okay? Okay, when you get your general, okay, and you already have your tech license, it's already on the FCC database, you don't have to wait one more second after that. You can go to the parking lot, turn on your radio, and use all of your general privileges. All you need to do is add /AG to your call sign. So for example, okay, I passed the test. The ink is not dry on the test yet, okay? I go out to my car, I turn on my ICOM 7000, and I go W2 BMP/AG, okay? And if I go on one of the bands that I'm not allowed to under technician, but I am allowed under general, then if I make a contact, the fact that you said /AG, remember it's /AG, not -AG, not $AG, it's /AG. Why do I mention that? It's a question on the test, right? So I say W2BMP/AG, then the contact is valid. Then nobody gets upset. Is the minimum channel separation. So continuous wave, Morse code, it's the smallest, okay? Notice that this is in hertz, HZ, not kilohertz, not megahertz, just hertz. So CW needs from 150 to 500 hertz. That's tiny, okay? Single sideband, 3 kilohertz, 3,000 hertz, as opposed to 500 hertz. So you need to know that channel separation, okay? This stuff I'm going to ask you for the next 4 sessions until you're upside down and backwards, okay? These you already know, 3 dB, 6 dB, you knew from your technical. Now we added 2 more. 20 dB is 100-fold, okay? And 1 dB loss. That'll definitely be on the test. All 5 exams have this question, okay? Under data modes, what you need to know is PSK 31 uses Varicode. I'll explain that to you. RTTY uses 5-bit Bordeaux code, okay? It's the only French name that is on the exam. So RTTY, 5-bit. RTTY, 5-bit. That's what you need to know, okay? And RTTY can only send in uppercase letters, okay? All right, cool. They're going to ask you when you can use, when you should use lower sideband and upper sideband. Here's the answer, okay? So below 14 megahertz, use lower sideband. Above 14 megahertz, use upper sideband. That equates directly to 20 meters. Okay? Got it? All right. If you have any questions, let me know. Okay? Then, because they assume as a general you're going to want to make HF calls all the time, and you're going to want to talk to people all over the planet, they want you to know about propagation, okay? And the A index, and you can get propagation. We'll go over this. I'll show you a couple of websites where they record this information. A index is long-term geomagnetic stability. The Earth is magnetic. How that magnetic field affects propagation is important. You need to understand that. If you want to know why you can speak to China but you can't speak to California, that's the reason why, okay? And K index is short-term geomagnetic stability. It normally changes every 24 to 28 days, some in that area, generally, okay? And we measure the influence of the sun on 10.7 centimeters. It's always measured, the effect that the sun has on the planet at 10.7 centimeters. It's just a standard that they selected. If you want to know why 10.7 centimeters, you need to take the extra class. Okay. Then they'll talk about the layers, okay, and these are the layer informations that you need to know, all right. And then again, you're just going to have to play with that and learn it a little bit, okay. And they're going to ask you what MUF and LUF means. Maximum usable frequency, lowest usable frequency. Okay. The next part, they love to ask this question. Okay. Okay. Let me explain this question to you. So the sun is 8 light minutes away from the Earth. So if the sun would normally, if the sun would just all of a sudden go dark, we wouldn't know about it for 8 minutes. So the light traveling from the sun takes 8 minutes to arrive on Earth. Okay? UV, ultraviolet, and X-rays are a form of light. Okay? They're in the same spectrum. Therefore, they take 8 minutes to arrive to us. Okay? So if there's a UV spike or an X-ray spike in the sun's atmosphere, it'll take about 8 minutes for it to reach us. Okay? When the sun has an eruption, which it has all the time, okay, it's called a coronal mass, and it takes about 20 to 40 hours. That radiation is different than UV and X-ray, and that effect takes 20 to 40 hours to reach us. So just a few days ago, there was a coronal mass ejection. We knew about it the day before, and it said, don't even bother taking out your HF sets because you're not going to talk to anybody. But it did affect some TV stations here in New York and some AM and FM stations as well. So it affects all radio transmission, you know, TV and regular conventional radio. Okay? All right, cool. Then they're going to talk to you about tuning your radio. And the reason that they're going to talk about this is they want to make sure that your radio complies with the current standards. So any machine made by man or woman fails over time, and radios will, in fact, go out of alignment, especially the older radios. Not so bad the new stuff, but when I talk about the old radios, 10, 15, 20 years, especially tube radios and that kind of stuff, they tend to go out of alignment, and they talk about the different tests that you can run on your equipment to make sure that it's transmitting on the right frequency. Remember, if you guys remember, when we were using HF, you can tune minute amount of frequencies here. I mean, you know, in the single hertz range, even finer than that. So they want you to make sure that if you think you're transmitting at 14.070, that you're actually transmitting there. And if that's not the case, and somebody says, I hear you on a different frequency, they want you to understand which tests you need to run to make sure your radio's in alignment. Otherwise, we'd have people all over the place, right? Robert says, Joe, at some point, are you going to give an extra class? Yeah, I am. Boy, you're just ready. You just want a lot of abuse here, huh? Okay. Yeah. Yes, Robert, I am going to give the general class. As soon as I come back from vacation, I think. Anyway, Q signals, you have to learn a couple more. This one is a piece of cake. If you get this one wrong, I'm going to be very, very upset. Okay, so that's me. Okay. QRS, send slowly. QRQ, send faster. QSL, acknowledge. QRV, ready to receive. And this is used for digital modes and Morse code, KN. Okay. So you would type in KNW2BMP. So you don't want to talk to anybody except me. CL is close. You're closing the station down. You're turning the power off. And AR, end of message. Okay? All right. So everybody good so far? We're almost done with this. We're done with page 1 already. There's only 2 pages here. The reason for this question is because they don't want you plugging in your 100-watt brand new ICOM 7100 that you spent $1,400 into your cigarette lighter. That's the reason for this question. And you would be surprised how many people pass their general and do exactly that. No problem, I can do this. No, you can't, okay? What you do is you smoke your car and probably smoke your radio, okay? So they want you to know that as the amperage goes up, you need a thicker wire, okay? That's all this means. And they specifically address this 20 amp one, okay, a lot. So don't hook up your 100-watt radio to your car without using 12-gauge wire. And I guarantee you that the wire from your cigarette lighter or accessory port is not 12-gauge wire, okay? Next class, I'll show you what 12-gauge wire looks like. It's really thick. Your car doesn't have this. And they don't want you to set fire to your car, okay? All right. Then on page 2, we're going to talk about this stuff a little bit more in detail. So everybody have the calculator handy? Everybody say yes. Okay?
Yes,
Yeah.
we do.
Yes.
All right, cool. So I'm going to teach you how to handle these things, okay? We're going to spend a few minutes talking about this because the next chapter I want you to have in your mind is chapter 4. And I don't want you to freak out, okay, when you see this happening in on the chapter. So let's go over it for 1 second here. Let me switch to this. Okay, let me get a pen here, and it's really super duper easy. I promise. And I have never lied to you so far, so you got to trust me. Okay. All right. So we talked about in our tech class 2 types of circuits, right? So we talked about the Christmas tree, right? So here we put a resistor in here, and then we put a resistor in here, okay? And we have that hooked up to a battery, right? I'm going to try to draw the Energizer bunny, okay? Man, that's really a sick bunny. Anyway. So you have it hooked up to here. This is series circuit, right? Real simple, okay? And these are resistors. That's my feeble attempt at drawing a resistor. When we want to calculate how much the total resistance in the circuit is, okay, it's very simple. We take resistor 1, and we add it to resistor 2, and then we add it to resistor 3. So if I said the first resistor is 10, the second resistor is 20 ohms, and the third resistor is 50 ohms, what would the answer be?
80.
80. Okay?
80.
This is in series. This only works for series. So in series, we add these suckers together, okay? Very simple, okay? Series only, very important. If we have a parallel circuit, we have our Energizer bunny, right? And we split it, and we have resistors here, and then actually we have another one here, and then down here. So we do this in series, okay? The question is, how do I handle this? Well, in series, it's different than it would be in parallel, all right? So in series, we take 1 over 1 over resistor 1 plus 1 over 1 over resistor 2 plus 1 over 1 over resistor 3. And everybody's going to totally freak out. How can you possibly compute this? Okay? No problem. No problema. Okay? So I want you to look at your calculator and just look at it. And on talking from the top of the calculator, you see the on-off button, right? And then you see the second button, which should be yellow. Underneath that, it says HYP. Underneath that, it says pi. Everybody see the pi button? Okay. Move 1 over from the pi button on the right. You'll see 1 over x. Okay?
Yep.
See that 1 over x? That's your new best friend. Okay? What the 1 over x is, it calculates all of this. Right?
Thank God.
It does all of this for you. Okay? So, in a parallel circuit, all right, I have the same 20 ohm plus 30 ohm plus 50 ohm, right? All right, here we go. Ready? So what I'm going to do is I'm going to turn the calculator on. I'm going to hit the clear button to make sure it's clear. And I'm going to type in 20, 2, 0, and hit the 1 over x button. What do you get?
0.05. 0.05.
All right, 0.05. Beautiful. Now we're going to add 30. So you're going to take, and you're going to hit the plus, right? So you're at 0.05. You're going to hit the plus button, which is right on top of the equal sign. Then you're going to do the same thing for 30. You're going to type in 30 and the 1 over x, and that's going to give you, what do you got for that one?
0.03. 3333.
Yeah, 0.033. That's close enough. And then you're going to hit the plus button, right? Plus. And then you're going to hit 50. And you're going to hit the 1 over x button again. What do you get?
0.02.
Yeah, that's right. All right, now we're finished with the adding. You're going to hit the equal sign. Okay?
Yep.
And what do you get?
0.10.
0.103.
Right, 3333. And then to get the answer, you hit the 1 over x button one more time. And what answer do you get?
9.67.
That's it. That's how you figure this out. That wasn't so hard. Right?
Hey, Joe,
Yes, sir.
where is the 1 over X button? I can't find it.
Sure.
Calculator.
It's if you look on the left-hand side of the calculator, you have the second button in the upper left-hand corner.
Got
You go
that?
down one, it says HYP, right?
Yep. Got it?
Underneath that is the pi signal, the
Got
pi
it.
sign, rather.
Right.
And if you look to the right of the pi sign, it's the 1 over x.
Oh, got it. Okay. Gotcha.
All right?
Okay. Thank you.
Okay, so I don't want you guys freaking out on Chapter 4 because we don't need to do the math. That's why we have a calculator. That's why I told you to spend the $10 on this. Spend the calculator.
Hey, Joe,
Yes.
I don't understand why you hit after you got the total, you hit the 1X button again.
Okay, because what it's computing is computing this as an inverse, and you need to calculate that and put that back into a real number. It's computing as a reciprocal. So these numbers that you got, this 0.05, is the reciprocal of 1 over resistance 1. That's what this 20 is. So when you hit the 1 over x button, you're getting these values, which are reciprocal values. They're called reciprocal values. Okay? And what we need to do is convert them back into a number that we know how to use. Does that make sense? Okay. Because we don't want you to go through this. Okay? You know what? If I had to do this, I mean, I use this math all the time. If I had to do this, I'd blow my brains out. I don't think I could remember how to do it manually anymore. Okay? So we don't want you to worry about all of this stuff. Okay? That's why we have these calculators. All right? So what you do need to worry about, however, let me clean this up here. All right? And I'm going to send you a sheet tonight, okay, explaining this in detail again, because it's very important. Once you have this calculation down, then you can figure out anything in Chapter 4. It's really that simple. What you do need to know, okay, is that what the difference is in series as opposed to what the difference is in parallel. The only thing that you can add together, okay, as far as resistors, is in a series circuit. So if you're talking about resistors, the only time you add them together is in a parallel circuit. The same thing for inductors. Resistors act very similar to inductors. Okay? So what applies to resistors applies to inductors. So in a series circuit, you add them together. You can do it in your head, no problem. If it's a parallel circuit, they'll tell you this information on the question, then you have to use that 1 over. Anthony, would you be kind enough to mute your phone, please?
Oh, sorry.
No worries, no worries. So you need to know this. The opposite of that is capacitors, those pesky little capacitors, right? So in a series circuit, use the 1 over thing, the reciprocal, and in the parallel circuit, you add the capacitance values together. Okay? That's as hard as you need to remember, because you now know how to figure this out. No problem. Right? Okay, cool. So I'm going to open up this sheet here, and I'm not going to let you see the answer here. Okay, so here's the question. Okay? The question is, I'm going to send you this sheet tonight, okay? What is the equivalent resistance of a 20 ohm, 50 ohm, and 75 ohm resistor in parallel? Go for it. The first one to give me the right answer wins a brand new Mercedes-Benz 300 E-Series. No, I'm only kidding.
.013?
Nope.
No?
Try again. And if you look at the bottom of the page, it tells you exactly how to get it.
12? 12.
12?
Oh, all right. That's exactly correct. Can you see? The answer is 12 ohms. Okay? Now, Kevin, AB2ZEI, he's a really good friend of mine. He's an excellent, excellent instructor. Came up with this really cool sheet, and he took little pictures of the buttons so you can see exactly how to figure it out. So I'll send this to you, okay? But this is, so when you look at all these formulas and everybody freaks out, it's not necessary to freak out. It's really very simple. Did anybody not get this answer? Karen got 11.86. That's pretty close to 12. Okay?
Yeah, I forgot to hit the equal before I hit the 1 over x again.
That's fine. That's fine. All right. I want you to practice this so you're not afraid of this anymore. It's very, very simple. Remember to follow the process. So it's the button, right? It's the button, then press the plus, then the button, press the plus, press, the button, enter the number, press the button, hit the plus, just like you were adding numbers together, which is what you're doing. You're just adding reciprocals, okay? And if you get stuck, he goes through it step by step, and you'll end up with this answer, okay? and practice this a little bit. A couple of times, you got it. No biggie. No biggie at all. Okay? I promise. I'll send you that tonight. Okay? Then this question they love to ask. Reactance. Reactance increases with frequency in a coil, decreases in frequency with a capacitor. Okay? Know this. It's just a general rule. Okay? All right. And then they're going to ask you why you need to have impedance matching, i.e. a tuner. Okay? Matching impedance between source and load, source being your radio, load being the power that's coming out of it, and to your antenna. Why do we do that? For the maximum power transfer and the highest efficiency. Okay? Again, I'm going through this real quickly, but we'll go over it in a little bit more detail in the next couple of classes. Okay? DE9 is the old serial cable. I'll have one for you. Okay? It's the old serial cable that got connected to the old computers. DIN is what connects your car radio to the wiring harness. It's circular normally. Sometimes it's square, but more normally it's round. Okay? It's got a bunch of little connectors in it. It's a thing you can never line up correctly, and you always end up bending a pin. RCA, I'll have one of those. It's how you hook up your stereo. Okay? Just a very simple connector. PL259 is the connectors that we use for our radios, and they're good all the way up to 150 megahertz. N connector is a waterproof typing connector. An SMA, if you look at the top of your Baofeng and unscrew the antenna, that's an SMA connector. Okay? All right, cool. You should know these components, all right, already. So the one that's got the bar upside down going straight up and these leads coming out at right angles, they're field effect transistors. Hey, for the guys that took the test, was a field effect transistor on the test? Just curious.
Hey Joe, the FET was on my test, but so was that DIN connector. That was the one that threw me off. I know I had heard of it, but I didn't know it was audio.
Yeah, yeah. Well, it carries more things than audio. DIN carries audio, left and right, front and back speakers. Most commonly used in cars. It also carries power and sometimes a signal to raise or lower the antenna or whatever. So DIN is multi-conductor. Yeah. All right, cool. So field effect transistor looks like this, and it's got these little guys at right angles. These are the things I'm most interested in, you know. All right, so these little wires are at specific right angles to the gate here. And remember, we know it has a gate because in order to get to the field, you go through the gate. Right? Everybody knows what this looks like. It's a diode, right? Roach Motel. Electrons go in, but they don't come out. Only this one's got a really funny shaped Z. This was Zorro after a couple of shots of tequila. Okay? And this is known as a Zener diode. And you can tell because it's got a Z. Okay? And then anything with a circle is a transistor, only they want to get you a little bit fancier now. Okay? And they have a little arrow pointing out. There's two major types of transistors. Actually, three types of transistors. NPN. And NPN, you can tell, is because the arrow's going out. PNP transistor, the opposite of this, PNP, the little arrow would be pointing in. Okay? All right. This is a transformer, which are really nothing more than two inductors. Okay? And a tapped inductor, okay, is an inductor with a little wire sticking out of it. Okay? All right. This is the dumbest part of the exam I have ever seen. They have never changed this question in at least 20 years. Why you would need to know this is totally beyond me. Why they ask you that, you should know this, but you should be able to look it up, you know, in the schematic or in the manual for the radio. You shouldn't have to know this off the top of your head, but you do, okay? So two major types of diodes, germanium and silicone. Germanium, 0.3 volts, silicone, 0.7 volts. Don't ask me why. Don't ask me the reason behind it. I have no idea, okay? Because you're going to have to look it up anyway. All you're going to see is a picture of a diode, and you're not going to know what the value of that diode is. You're going to have to look at the service manual to say, hey, by the way, this is a silicone diode. It should be 0.7 volts. All right, whatever. Peak envelope power. You're going to need to know this formula. Don't worry about it for right now, okay? So this is the peak power that the signal is processing through one complete cycle. Peak to peak voltage, okay? So let's see if I can, man, I hate this new interface with all my heart. I'll tell you what, if you come back for the extra class, I won't be teaching it on this guy. This is just horrible. Okay, so here's our wave. All right, so from the top to the top on the top to the top on the bottom, that's peak to peak voltage. What this is, whatever this value is, peak to peak voltage. Okay, and RMS, root mean squared, we'll talk about, and you'll need to convert from peak envelope power and peak to peak to RMS. No big deal, right? If I was able to explain that whole 1 over thing to you in two minutes, this is even easier, okay? So please don't worry, okay? All right, and just to emphasize that you shouldn't worry, okay? They add one more to your EIR and pi, okay? They add this one, okay? Again, don't worry about it too much. I'll show you how we can compute this easily. Don't get too crazy about it, okay? We're then going to talk about logic circuits, okay? And logic circuits are binary, and the ones you need to know are AND and NOR gates, okay? So AND gates, we'll talk about. What you need to know is they are on when both inputs are on, and NOR gates, output is low when either or both outputs are high. So the opposite of each other, okay? All right. Then they talk about antenna lengths. Now, I told you, but I did warn you, that what I was telling you was not absolutely accurate. And I told you that for any band, okay, all you have to do is multiply by 3, because a meter is approximately 3 feet. Well, I lied. I didn't lie because I told you it wasn't. It's actually 3.28 feet, okay? So they have these new formulas for you to figure out dipole length. Oh, excuse me. A little bit more accurately. And this is a little bit more accurately, okay, than what I told you in the technical class. So to figure out dipole length, it's 468 divided by the frequency in megahertz. Don't stress over it. I promise, okay? When we talk about different antennas, we'll get into this. You'll see how easy it really is. The thing that you must memorize, because that's just the way it is, some things you just need to memorize, is a 3-element Yagi. The maximum theoretical gain is 9.7 dBi. So as compared to the perfect Yagi antenna, the isotropic antenna, that's what the I stands for, the maximum gain you can get is 9.7. Is that true? No, but we need to know it for the exam. Okay? So are we all cool with this? That's as hard as it gets, I promise. I promise, I promise, I promise. So if you kind of followed most of it, you're good. Okay? All right, cool. So let's go over, we're going to go through the manual unless there's any questions. I'm going to go through the manual really quickly, Reader's Digest version on steroids. Okay? because we have a lot to cover, and I'm going to go through it as quickly as we can. If you need me to stop, yell out, stop. I'm going to put my chat window here so I can see the chats going on if somebody chats me or texts me. All right, here we go. So this is why you should become a ham, okay? It's really cool. You know, you get to talk to a lot of people, blah, 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 blah. All right? You should join the ARRL, okay? They give you a whole bunch of cool stuff. You can win all these awards. These are a bunch of people out there. This is some guy camping in the middle of no place with his radio. Okay, whatever. As a general, you're going to end up with more privileges. You have almost the same privileges as extras. You're allowed to go up much higher in power. We will discuss that at length, okay? We want you to be careful. That's why we call the classes be careful, don't hurt yourself, don't nuke your dog, which is the class you're taking now, and the extra is please don't nuke your neighbor's dog, okay? That's why they're called that way, all right? The ARRL is the greatest thing since soap and water. Yeah, okay. The reasons to upgrade, you have more communications options, you have more frequencies, you can play on HF, that's the ham band plan, a lot of. Ask me if I remember any of those. For your general exam, it's the same as your technical exam. There's 35 questions, 26 is correct, okay? Morse code, not needed. You don't need to worry about it, okay? You don't need Morse code for anything, okay? How to use this book, read it, okay? The question pool, blah, 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 blah. Okay, cool. And they talk about this is what if you haven't taken your test, this is exactly what it looks like. A bunch of really old farty guys standing around there, and they have this little template. You answer the questions, but you have to be an extra or a general for this, and we'll talk about this in 1 second. Okay, as generals, you are permitted to sit as a volunteer examiner, okay? You may only give or grade an exam for a technician. That's it. You cannot, as a general, give an exam to another general candidate. No. Only technician. So if you're in a room with other VEs, you must let them know that you are only a general because you're only allowed to grade technical exams. If you grade a general exam or an extra exam and the person passes and they find out that you're a general, those are voided. The person must take the exam again. Don't look at me. I didn't make up the rules, okay? That's the dumbest thing I've ever seen in my life. It's really a template. For those of you that took the test, you know exactly what I mean. It's a plastic template. It's got a number on it, so test number 4. We put it on your answer sheet, and we count the number of the ones you got correct. And then if you got more than 26, we sign off on it. And if you didn't, we check off failed and sign off on it. For that, you need to be an extra. I don't get it. All right, anyway. So they will ask you a question. I guarantee it. It's on all 5 exams. Is who you allowed to examine, and it is technician only. Period. That's it. And they devote 2/3 of a chapter onto that. I don't know why they do that. Excuse me. All right. So this is what the application looks like. That's what the exam looks like. These are all kits that you're going to end up building. I hope you guys in the fall sign up for the kit building ones. We have a blast with this. And we built some, I like Tony Park's kits, and you can get on HF really inexpensively, okay? Then they talk about the sub-element things and how the exams are divided up. And the reason that you need to know this is because you don't need to know this for the exam. But the reason they put this in your manual is because you can apply for your VE. You get a blue badge instead of a white badge, and you're allowed to give out FCC exams. Okay? So that's it. Any questions? We good? You just did Chapter 1. Okay, cool. A lot of the stuff I discussed with you in the technician's exam, you know, with this big tuning knob, that's a VFO, variable frequency oscillator, right? No biggie. Okay, good practices. We practiced this, guys. I know we did. CQ, CQ, CQ. Okay, CQDX, right? Means long or distance station. Okay, and then I taught you how to break in to something. Okay. Again, we're going to be courteous. Blah blah blah. Selecting a frequency. This whole big thing is just listen. Okay. Listen first before you just start transmitting. That's all this means. Okay, they talk about this. Remember, this was on the sheet as well. I want you to know these two, okay, a lot. CW, 150 to 500 hertz, just hertz, okay. SSB, 3000, okay, and we know what all of these things. So if I said to you, hey, Tony, how are you?
Hi.
Hiya, Tony. Hey,
Hi.
Tony, if I wanted to say I wanted to do a QSO with you, QSO, what does that mean?
That's a low power transmission.
QSO. QSO. Hey, Robert. That's it. You blew it, Tony. Robert, what's QSO mean? QSO.
Breaking in.
No, QSO just means have a conversation.
Yeah, just conversation.
Yeah, I just want to have a conversation with you. QSO. A QSO. We call them QSOs. Okay? All right. I didn't expect you to know that, guys. So I'm just, in my usual teaching style, I'm trying to get you
Thanks, Joe.
No problem. Hey, it's my pleasure. All right.
That's
So
all right. Get
listen.
us involved.
Yeah, absolutely. This is interactive. What I do want to talk to you about is this, okay? So technician, not so much. General, you got to take a little bit more precaution. You're going to need to have a logbook, okay? There's electronic ones. They're all free. Just Google, amateur radio logbook, ham radio logbook. There's only about 52 million of them on the Internet. They're all free, okay? The reason you need to know these and have this, a lot of them are automatic. Mine are automatic, but on my radio. So as soon as I make a contact, it enters it into my logbook. Why? Because you're going to be making very long distance connections. So my wife and I hope to go to Japan, right? If I'm in Japan and I'm talking to you, Robert, here on Long Island on 2 watts, right?
That's
So
pretty
I'm
cool.
reaching from Japan to you in 2 watts. And I send you a QSL card, and I register that with the ARRL. They're going to turn around and tell me I'm full of crap. There's no way I could have done that. So they're going to contact you to validate that. And if you don't have it in your logbook, and it doesn't match what I'm telling them, okay, they're not going to give me credit for this. All right?
And then you're going to come over and strangle me.
No, I wouldn't do that. But however, I wouldn't be putting up any antennas in your house because I know how to shut them down. Anyway, the point is, a lot of people take this seriously. For me personally, the fun of it is to try to reach. There are guys that have done around the planet on less than a watt, on milliwatts, like 800 milliwatts, right? I mean, that to me, that's the fun of it. That's the challenge of it. Anybody can do this at 3,000 watts. It's doing it at less than 1 watt. That turns me on. I like doing that. So if I'm someplace far away and I'm trying to reach Robert here on Long Island, or if I'm in Japan or Asia or Russia or someplace, heaven knows where I'm going to be next year, and I talk to Robert, I want to get credit for that. So, that.
Hey, Joe, I lost you. I don't know about anybody else.
We all did.
No, I lost you.
Yeah, I lost him too. I lost him too.
You must have gone to Japan.
Yeah.
I think I'm going to reboot.
Turn his wattage up.
Yeah, he's a QRP guy.
How about now? Is that better?
Much better. That's
Can you
much
hear me?
better, Joe.
That
All
works.
right.
What'd you do?
Man,
Turn
I
up your
hate-
power?
No, I hate this. I hate this new go to meeting. I'm going to switch to the other one, whatever the other one is. This is awful. Oh my goodness. Sorry about that, guys. Okay, everybody can hear me, right? If you can't,
Yes.
text me. All right, cool.
He can
So,
hear you.
all right, good. So I want you to be involved with these things, okay? I want you to know about this. Also, it's a blast to get QSL cards from all over the planet. You know, so it's important that you maintain these logbooks of some type, especially when you're not on 2 meters or 70 centimeters. Nobody really cares about that too much. Although you will get long distance occasionally. I just talked to somebody in Nevada the other day on 2 meters. So it is possible. But on HF, these people do take it very, very seriously, okay? Especially the guys doing contests. And they get all bent out of shape if you can't validate what they're saying, okay? So that was just, remember, you're taking a step up here. So now you're into a more professional class of radio.
Joe,
Yes.
if you can, could you, I guess, as an example, after the class or whatever, show us how that automatic logging happens? Because
Sure.
when I
Sure.
try to log it by hand, I can't keep up.
Yeah. It takes a little it does take a little practice. Actually, I'll make it for the next class because my radio is not hooked up at the moment. But I'll have it set for you for next class, and you can see how it works. Yeah, it records the frequency and the time, and all you need to put in is just the person's call sign. And guys and ladies, please don't be afraid to go slow. If you can't hear them, you can't hear them. Okay, I know people that do. You know, my call sign is "Hey Ted, is that?" And you go, "What?" I'm sorry. Can you say it again? Absolutely. Go ahead. And you know, hey, look, I'm asking you to do it slow. So the same thing happened to my wife yesterday. She was on the net. It was a station that was far away. She couldn't hear him. It's okay. You ask for it as many times as you need to ask for it. Don't be embarrassed. Don't be whatever. They're obligated to give their call sign in a distinguishable, meaningful way. Okay?
You know what I was doing?
Yeah.
I was actually using my iPhone and voice recording what was going on so I can go back and listen to it.
Yeah, you know what? And that happens to everybody. It certainly happened to me. I couldn't remember a call sign to save my life. I just couldn't. And you know what? After a couple of weeks, it just poof, and all of a sudden you kind of get the hang of how they're talking, and it's not so bad anymore. So hang in there. It gets easier. Okay. CW, everybody knows what that is, right? Continuous wave, AM and single sideband. We know all about that. All of the transmissions on HF are on sideband, virtually all of them, because your signal will go further. Okay. Digital modes, we know what they are: CW, RIDI, PSK31, blah 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 blah. Okay, cool. All right, and then we get into image modes. Okay. Also known as visual modes. Visual modes are can be pictures. Okay, they can be slow scan television. Slow scan television, which is not the greatest thing in the world. Frame by frame, you can send pictures, all of that kind of stuff. Okay, and here they talk about the different bandwidths. The ones I need you to know for the 50th time. Know this one. And know this one, okay? Those are the ones I need you to know, okay? So I've said it 11 times, okay? So that's why I would say that, because it's on the test. It's on the test, okay? All right, cool. All right, mode comparison, just different modes you can listen to. I'll demonstrate that next week when my radio is on here. Somebody's got their phone not on mute, and I'm going to find out who that is. Oh,
Hey,
no.
Joe, you got to hang on. I changed my headset, and I don't have a mute button on this. Give me 1 second to figure out how to do this.
No problem. No problem. Thank you. I appreciate it.
I apologize.
No worries. No worries. Okay. So HF receiving, they talk about different filters that you can use, preamplifiers, what you can do to get the signal a little bit closer to you, okay? And you will use those filters on HF, especially when you're talking to a faraway station. One of the most wonderful experiences I've ever had is people climbing mountains, and they'll stop, for whatever reason, and they'll get on the radio. Because of their altitude climbing the mountain, their signal goes a lot further. So on a 5-watt backpack radio, I can talk to people, on the Himalayas and all over the place. And you need to listen carefully to them and try to filter out the noise. So we talked about some of these filters in the technical class, and we'll go over them in a little bit more detail. The point that they're making here in this chapter is that there's a bunch of stuff that you can use to filter out the interference, okay? And they also talk about this new device, which we just considered 2 weeks ago in our technical class, called the RIT, Receiver Incremental Tuning, or, as I like to call it, the fine-tuning knob, okay? All right, cool. And then they talk about when you're transmitting, they talk about Vox gain, so you don't have to push the button, right? We know all this stuff. If you don't know this stuff and need me to go over it, let me know, all right? But these are all different cool things you can do to transmit out, and you'll play with them. They're not on the test, so don't worry about it, okay? All right. The thing that we want you to know is CW is not required for any class, including extra, okay? But CW will always, always, always get through, always. And on HF, you'll hear more CW than you hear anything else, okay? So if you end up buying a radio, one of the modern HF radios, you can hook them up to your computer, as I do and as I did, and to demonstrate to you, that decodes Morse code for you. All right, and I'll demonstrate that again for you at the next class. And that's a great way to learn CW. After a while, you don't really need to know what those dits and das, or dots and dashes, we call them dits and das, actually mean. After a while, each letter you'll be able to pick up, okay? You'll be able to kind of identify just by watching the screen go by and matching it up. Also, there's some great programs that are free, Morse code trainers, and some radios even have Morse code trainers built in, okay? So although I'm suggesting to you focus on getting your general, done, and that's great, you'll also see when you get your general that a lot of the people, most of the people, are on CW or some type of digital mode. So be ready for that, okay? And don't stress about learning it so much. Just listen, and if you decide that you want to get into it, great. CW on 10 watts is better than phone at 100 watts. You'll get further, you'll talk to more people, and it's a whole nother world. It's a whole nother world. And after a while, it becomes second nature. You won't even know, you don't even think about it. Excuse me. All right. So here they talk about CW procedures and abbreviations. You can go through it. The ones that you need to know, QRS, send slower, okay? QRQ, go faster. And the end is K. And sign it DE. DE means from, okay? So I'll sign 73DE Joe W2BMP. DE means from, okay? All right, cool. All right, and so they go over these. It's cool to know. The ones you must know are on your study sheet. All right, that's the ones you must know. And don't worry about knowing all of them. Just the ones that are on that sheet. One of the questions you may see is the zero beat. Okay, what does that mean? Zero beat means that you're transmitting and receiving on exactly the same frequency. Because you can vary frequencies so minutely on HF, sometimes you think you're on the right frequency, but you're a little bit off, just a little tiny bit off, and the person will tell you, okay? They'll tell you that you're not on the right frequency. They'll tell you I'm on 14.070 and you're on 14.075. And
hey, Joe?
Yes?
Is that more of the fault of the radio that you're on or your programming of the radio?
Yes. Yes, the answer is yes. It's,
so
it's like anything else in life. It's, first of all, I love this class. I love this class. Everybody gets so excited. Everybody gets so excited when they get on HF and they're talking to somebody, when they hear somebody, and they'll say, whatever they say, W2BMP, blah, 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 DX China, and they're in China. So I'm in China, and you're going to talk to me, and they get all excited. So what happens is you're not exactly on my frequency. Or it could be that the radio you have, after your kids have dropped it a couple of times, just isn't quite as tuned as it should be. So the answer is it could be both, okay? But we'll be able to tell. So we're going to do some HF stuff here and next class. Well, actually not next class, but the third class. And you'll hear as we start to approach the right frequency, the guy starts to sound like a chipmunk, or he sounds like he's had some nitrous oxide or something, or helium, that's it. And then as we tune down, you'll hear that his voice sounds better, okay? So when his voice sounds as clear as we can get it, that's zero beat. I just wanted you to know what zero beat means, okay? All right, cool. Digital modes, the ones that you need to know are on your study sheet, okay? And of course, we all know that the frequency where no phone is allowed, Anirudh, no way can you have phone on this band is
30.
All right, good job, good job. Please, 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 okay? All right. They will not be happy with you, okay? RTTY, the most popular, RTTY uses 5-bit Bordeaux code. It's on your study sheet. Every time I say RTTY, you say 5-bit Bordeaux, okay? And I'm going to, so I warned you. Anybody not get that, right? I'm going to say RTTY. I'm going to pick on somebody, like at random, like Andy. Hi, Andy.
Hi. Is this the Andy you meant? I know we had another.
Yeah, Andy Perla, right? Andy? Yeah.
No, this is Andy Eubanks.
All right, that's fine. I'll take you.
Okay.
Okay. I say RTTY, you say?
5-bit Bordeaux.
Okay, cool. That's all I wanted to know. Thank you. Hey, Richard Lee, how are you?
Just fine, Joe. Good evening again.
Good evening, sir. RTTY. I say RTTY.
5-bit Bordeaux code.
Good. Andy Eubanks. I say RTTY.
Yeah, I already answered 5-bit Bordeaux.
I don't care. I want to hear it again. And Judy? Hey, Judy?
Yes, sir.
Judy, that's what question I'm going to ask you.
You're going to say RTTY, and I'm going to say 5-bit Bordeaux.
Excellent, excellent. All right, good. Excellent job. Thank you so much. Okay.
Can I get a little Bordeaux?
Yeah, I know. It sounds like a wine. All right, so I definitely want you to know that. Next class, I'm going to ask it just whenever I feel like it, and you're responsible to know that, okay? All right, cool. Packet and Winmore, different types of, we discussed this briefly in the technical. We're going to discuss it quite as briefly here, okay? What these protocols have is better error correction, They send packets over. They send data over as packets. They do have some error correction. RTTY does not have any of that stuff. Okay, but next to CW, RTTY gets through a lot further than any of these other things. Why? Because it has no overhead. Okay. All right. Cool. So if you are not happy with CW and you want to try your hand at RTTY, especially if you buy one of the new radios. I was asked about the ICOM 7000, for example, which is an older radio. That decodes RTTY right out of the box. So it has a screen, and if you pick somebody up in RTTY, it'll decode it for you. Same thing for CW. The ICOM 7100 does that as well. The Electrocraft, all the Electrocrafts do CW, RTTY, all right out of the box. You don't have to buy anything. Displays it right on the screen. Okay. Packet radio was used pretty efficiently, but not so much anymore because it has a very slow rate. It's only 300 baud. Okay. PSK31 or its derivatives, sometimes they're called B as in boy, SK31, B as in Bravo, I should say. Okay. They're fast for radio. They are extremely error correcting. So narrow bandwidth performs very well, even very, very weak signals. So PSK31 is very, very popular. Hooks up directly to your computer. Next class, I'll show you exactly what you need to hook it up. Very inexpensive, okay, to get working, and you can go really far. You could actually travel around the world with PSK31. Very popular. It's just a protocol. What does protocol mean? Just like a language, okay? Karen asked, what is overhead? When you send the simplest signal, let's say CW, right? It's just dots or dashes. Nothing to figure out, nothing to get in the way. If I mess up on the key, right, and I spell Joe with a Q, or no, that's Q is a bad example. If I spelled Joe with a B instead of a J, it's because I screwed up. Okay, I Morse coded you, I CW'd you the wrong letter. There's nothing. So if I mess up, you take it as you find it. Some of these digital modes where you use a computer, RTTY, for example, is what you see is what you get. Okay, whatever you type in, okay, is what comes out the other end. All right, and that also goes for interference. So if I was near a power station or a local power company decided to blow one of the condensers or transformers rather on the telephone pole, you would see that as garbage. Okay, and a lot of times you see garbage on the screen. So what's being typed is garbage. On these other protocols, they use error correction.
Did we lose him again?
Yep.
Yep.
Yeah, same here. We lost him.
Karen's faster at typing than we are.
Can you hear me now?
Yep.
Yep. Sorry about that, folks. I don't know what's up with this. Anyway, so where did you lose me?
Well, not too long ago, about 15 seconds ago.
Okay. So what these other protocols do is they have error correction on them. So it knows what it's sending out, and it's kind of listening back as to what's being sent out, and they will error correct, okay, automatically. So that's the overhead. But you need an algorithm, you need a program to figure all of that out. So some of these things, we call that overhead. It's what's necessary to get the signal out. Does that answer your question?
Yes.
Okay, good. Overhead just means what you need to get the signal, what you need to get it done. Okay. All right. Cool. All right. So these are other digital modes that they talk about. There are a gazillion of them. Okay. So when you get on HF and somebody says to you, I want to talk to you on MFSK16, okay, don't freak out. Your computer probably has that, okay. I think we have an Aries member here from Nassau County. Aries. Who's our Aries guy? David?
Yes,
You
sir.
Yeah.
Yes.
So you're with Aries, right?
That's correct.
Right. So we practice Aries on Monday nights, and we have this thing where we send out forms and spreadsheets. And David, did you ever participate in that?
I did once as we were setting up my laptop, but I don't have a sound card yet.
Oh, okay.
So
Well,
the way I was doing it is by keying the mic and holding it next to the speaker on the computer.
Yeah. Okay. And the reason I asked David is, David is big into Aries, as am I. We use MFSK16 to send those forms, and what that sounds like is like a bunch of whistles. Okay. And I'll try to have some demonstrations for you so you can hear what they sound like. Another popular one is MT63, uses 64 tones to send the signal through. The point here is that there's a million of them. If you look on my software, Ham Radio Deluxe, there's hundreds of them. There's contest ones and non-contest ones. You want to bounce off the moon, you want to bounce off of Jupiter, whatever. There's a gazillion of them, okay? I just want you to be aware that they are, so if you get these freaky little codes, they'll tell you MFSK16, you know that it's just a protocol, a slightly different language, okay? So don't worry about it too much. Okay, emergency operations, we all know my opinion on this and what the law says. The law says you do whatever you need to do, okay? Okay? But as generals, the tech guys are going to look to you and say, explain it to me, okay? So you kind of need to know what's going on, right? So you're working your way up the mountain, to where the extras are. They have all white hair and beards, and they have these white robes, and they sit in the Buddha position, and they ponder the fine essence of amateur radio. Well, you're kind of working your way up that way, up that mountain. So the tech guys are going to look to you and say, what does this mean? So you need to kind of know this, okay? So these are the emergency communications rules, okay? So a station in distress, you do whatever it takes. Civil emergency service, you do whatever it takes. Absolutely, and David will be there. David, just I need a couple of words on Aries. David is one of my Aries guys. He's one of the best.
Amateur radio emergency service.
Has it been a rewarding experience for you?
Absolutely, and you meet some great people in that group. People not only dedicated to ham radio, but serving the community during a disaster or emergency. And somewhat different than RACES, which is under FCC, and Community Emergency Team. Aries will deploy more readily for testing and exercising and community support, where RACES will only activate if it's requested from Community Emergency Response Team.
Thank you, David. So David, like myself and my wife and a lot of other people, big into handling this. So as generals, you need to know what to do and what constitutes an emergency. Okay. All right, cool. And they talk about Aries and RACES. David kind of summed it up better than anybody I could ever think of. And again, you know how I feel about that. Look into that. Okay. All right, cool. All right, that's it. Distress calls, the word we never, ever, ever say, Bradlin. Bradlin, how are you? Really doesn't want to talk to me. Hey, Bill. We'll pick on Bill. WA2 RPF. You with us, Bill?
I'm here, Joe.
Good. So what's the only word that will stop the Earth from revolving around its axis? There's one word.
Break.
That's the one. Okay. Bill, did you hear that answer?
No, I didn't.
It's break. Okay.
Break. That's it. Okay.
Okay. You say break.
That's what I was looking for. I knew it wasn't Mayday or SOS.
Okay, good. Mayday, mayday, mayday works great if you're a pilot or on any kind of ship on the sea. CW, it's SOS. On phone, it's break. You say break, people are dialing 911 already. Okay? So be careful with that. All right, cool. All right. And this is, again, you're going to be on HF, okay? And this is considered the Considerate Operator's Frequency Guide, where to be and where not to be. They kind of follow these rules sometimes, maybe, unless there's a contest going, then nobody really pays attention to these things. But you should. We want to train you the right way. You should know where things are, which is nice. One of the reasons you should have this manual. Okay? Don't stress over it. It's not on the test. Okay, cool. All right, Chapter 3, Regulatory Bodies. You know that we're in Region 2 of the ITU. Okay? And I have a question. Greg O'Neill. How are you, Greg?
I'm doing just fine. How are you?
Good, Greg. Greg, so when you get your general, right, you walk out of there and you walk into your car, and let's say your call sign is W2BMP, right? And you hit the transmit button on HF. What are you going to say your call sign is?
Wait, what was my call sign?
W2BMP.
W2BMP/AG.
Awesome. Karen Majors, I have a question. I forget.
Okay.
So Karen, so you get your general, right? And then you go for your VE, your volunteer examiners. Who can you give an exam to?
Only technical.
You're the best. You are awesome, okay? And that's what they spend this chapter discussing, okay? So, you want to be a VE? Okay, that was Ken. So you want to be a VE. It's an open book test. You can download the book for free off of the ARRL website. You pay $5. You take the test. It's open book, so you will pass, no question. The entire exam is about where to send the money. So when you pay your $15, where does that money go? Okay, that's what the exam is about. Okay, and you need to be 18 years of age or older. Okay, and you must hold a general class or higher license. All right, and they send you in about a month. They send you this badge. It's blue in color. Okay, and you're allowed to give examinations to technician only. Okay, advanced doesn't exist anymore. That's been done away with. They did grandfather it in, but they're not issuing any more new advanced. Extras, you can give the exams to everybody. Okay, and then you'll sign it. Okay, so you'll sign. Hey Ken, we're getting this like machine gun sound from your audio connection. Thank you. So what you'll do is there are 3 examiners, at least 3. There's always more, but only 3 need to sign. And then you'll sign your name and your call sign, and then they'll circle which one. And this is the person's ticket, the ticket you will get. Okay. And there's one coordinating examiner. And he tells you exactly what to do. Please, please, please be careful if you go in as a general to a VE session that this is not circled any one of these 2. It's the general and extra, because if you're a general and you sign off on an extra, that person must take the test again. I've taken that test. I do not wish to take it again. Okay, so you will not get a Christmas card from that person. I can guarantee you that. Okay. As a VE, you'll know, again, we just discussed this /AG. Okay, that's what I need you to know for that. Okay, and as an examiner, you're required, normally the supervising examiner or the exam coordinator handles validating that the applicant has 2 forms of ID. Okay? All right, cool. Frequency privileges, refer to the ham band. Certainly refer to the sheet, not the study sheet that I gave you. This is what an application looks like. You should know it because you're going to fill one out. Okay? All right, cool. And then, yes.
I have a quick question. When I took the general test last week, there was a question regarding if the station belongs to an extra and there's a tech in the station, when, under what circumstances can they use it?
Well, what do you think the answer is? What do you think?
I think it's only under the direct supervision and only on the frequencies that are allowed for techs.
Correct. That's correct. If the extra is right there with you and looking over your shoulder, okay, he is the station, he has control of that station. He's not going to let you like fry your neighbor's dog. Then you can go into, you can use, as long as he's supervising you right there, then you can transmit with extra privileges. If he leaves the room, you go back to whatever license you have. Okay?
Okay, that's true.
Yeah, that's the general rule of thumb. Okay?
Okay.
If he's not in the room, doesn't matter. You can come here. I'm sitting next to you. Knock yourself out. You know? Only because, again, I don't own any amplifiers, but if I did, you know, we don't want you, like, you know, killing the neighbor's dog. He's so cute. His name is Diesel. He's the cutest dog. And I love my neighbor. He's my electrician, so he can hurt me if I'm not really nice to him. He's wired my entire house. He knows where my antennas are, so I want to be nice to him. So you don't want to kill the neighbor's dog. Okay, beacons.
So Joe, in that scenario, does is the call sign that's used going to be the extras call sign? That way, if contacts are made, it's okay.
Yep. And the extra is absolutely responsible for anything that goes on, right? Okay. So if the guy's had a couple of tequila shots and he starts singing "My Old Kentucky Home," you know, to the space station or to anybody, I'd move if I were you. Anyway, beacons, okay? Beacons are maximum 100 watts, and they're all over the place. You can go and look up amateur radio beacons, ham radio beacons, okay? And the idea for them is they're all over all of the bands. If you can hear them, you can get there, okay? So the beacon will tell you what frequency it's at. It's always assumed 100 watts, all right? Sometimes it's not, but it's peak envelope power, and they'll tell you the location. So if I wanted to reach somebody in Alaska, I would go try to reach those beacons in stages. So I'd go from here to Minnesota, for example, and from Minnesota to Oregon, and if I could hear the Oregon beacon, then I would go over to Alaska, try that, and that's their purpose in life. Okay? All right, cool. And they're useful to coordinate also as well. So the beacons will clearly identify what frequency they're on. So when you dial that frequency, you should be able to hear them, okay? And if you can't, then, or you hear them on a slightly different frequency, then you need to take in your radio for an adjustment, okay? Or you can do it yourself if you know, yeah.
Joe, I got a question.
Yes, sir.
Real quick on beacons and repeaters. I mean, who pays for all this? It must be pretty expensive, repeaters and power and. I mean,
yeah, the clubs pay for it. So, for example, in my club, which I have the privilege of being the president of this year, we have 400 and I'm not sure if we have 400 members or 300 and change members. We have a lot of members, and they pay dues, about $35, $40 a year. Plus, we have a ton of ham fests and other fundraising events, and we're also not-for-profit organization because we're not for profit. Every dollar we get in, we spend on things like repeaters. So we rent space on the tower. David, correct me if I'm wrong. David is one of our members. David, I think we have 5 repeaters in operation currently.
I think that's correct.
Yeah, I think it's correct. And we have repeaters. So if you take out a map of Long Island, it's 208 miles from point to point. We have one at the furthest point, way out in Suffolk, or just about at the furthest point, and we can reach all the way into southern New Jersey, northern Pennsylvania, eastern Pennsylvania. We go up to Connecticut, so we have a very wide range. We're the second or third largest repeater system on the planet Earth, and it's all paid for by our members and the events that we run. I'm extremely proud of my club. All of these guys and ladies, and we have many women in our clubs that we could never possibly exist without. They'll get up at 5 o'clock in the morning to be at a show that we run, you know, and they'll work all day, and they'll work their tails off just to get money for the club. Plus we run 50/50s and things like that. Beacons are also generally run by clubs as well, and sometimes the guys who really donate part of it, and they don't really even know it, is pilots. If you join various pilot organizations, part of the money goes to setting up beacons. And the FCC also subsidizes beacons as well. Okay, so the nicest people on the planet Earth that I've ever known are amateur radio operators, ham radio operators, and they'll do anything for their hobby. And it's a blast. It's a blast. That's why you're here, right? Because it's fun. All right, cool. Repeater coordination. Okay. There is this mythical person. He rides a unicorn to work, and he's known as a regional repeater coordinator and a frequency coordinator. I've been doing this a very long time. I have yet to meet one in person. That's how I know that they ride in unicorns. So anyway, they're the guys who make up the frequency charts and all that stuff. Some mythical guy, have no idea who they are. Okay, next thing you need to know, okay, is that on some bands, we are not the only ones, nor are we the primary people allowed to be there. They are 60 meter, 30 meter, and 70 centimeter. Okay, the forestry department is who we share these with for the most part, although we do share them with other governmental agencies. FEMA, for example, sends its documents over 30 meters. Okay, that's why a phone is not allowed. Okay, they also use 70 centimeters. NASA uses 70 centimeters, 440, and that's how it's a backup communication system for the space station. Okay, 60 meters, mostly the forestry department. Okay, please be aware of that. Okay. All right, cool. Then they talk about definitions and rules and third-party communications. We discussed this as in our technical class. I'm not going to spend a lot of time about this. Okay. International considerations. Okay. These are the countries that, as of 2.5 years ago, we had when the manual was first written. These are the countries that we have third-party agreements with. Okay. And we can handle third-party traffic with. It's quite extensive. The list has grown since this was done. So you can check the FCC or the ARRL website. Type in international. Okay. All right. Cool. Prohibited signals. The only one you're not allowed to talk to, as far as a country that I am aware of, okay, is North Korea at the moment. Okay. You can't use anything that's considered a secret code. That includes the 10 code, okay? So 10.4 and all that stuff, not permitted, okay? And you can understand why, Okay, so if you go to Walmart and buy those little walkie-talkies, say whatever you like, because their range is very limited. Okay, limited to maybe a mile. Okay, ham radio, amateur radio, absolutely not. Okay, because there's virtually no range limit. So you can't use anything that can be considered a secret code. Okay?
So why are Q codes not considered secret?
Because it comes from Morse code. Q was a letter that wasn't used too frequently, and there is no word in English that starts with Q that doesn't have U immediately following it, right? So they use that to their advantage by saying Q and then another letter other than U, and then the operator knew this was some kind of shorthand. Okay, so it's accepted from the old telegraph days. Okay. All right, cool. So when is that ever allowed? It's only allowed to control a space station. Not something I think you and I are ever going to do. Okay, but also it's allowed for radio-controlled models, but they're limited to 1 watt. Okay, and we discussed this in the technical class. Okay, cool. Written records, again, if you're on HF bands, so anything other than 2 meters, 70 centimeter, it might be a good idea. They run contests all the time, okay? If you turn on your radio and you can't find a clear channel, they're having contests, okay? And the idea, as I explained to you in the technical class, is they try to talk to as many people in as short a period of time as possible. So you want to keep a log on there, okay? And all you'll hear is CQ, 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 blah, 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 CQ, 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 blah, 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 trying to talk to anybody. And then when you talk to them, you'll say W2BMP, whatever that other call sign is, and then read you 5 by 9. Your signal was 5. It was perfect. No matter how badly it really was, it's always 5/9. I heard you loud and clear. And they'll tell you number 63, and then you enter it into your logbook. All right. So in case he has a problem with the ARRL, or it's Joe Gomez talking to you from Japan on 1/2 watt, and you know ARRL doesn't believe you, then I want some validation from you. Okay. All right. Cool. We talked about all of this stuff. We're governed by Part 97 of the FCC rules. Transmitter and amplifier power. That's all in there. Good luck with that. Nothing really too earth-shattering. Okay, and then none of this is too interesting. All right, not too much to worry about. Okay, and then we're going to start with Chapter 4, and that's where we're going to call it an evening here. But I just want to go over this very, very gently with you, okay, so nobody freaks out over this. It looks a lot more daunting than it is. They go over basic stuff. This is word for word what was in your technical manual, okay? Exactly, the definitions are the same. They talk about this stuff, okay? We know about this stuff. Don't worry about it, okay? Don't worry about it. It's the same stuff over and over again. So we're going to talk about this in a little bit more detail. Again, this one you already know because I explained this to you, and you know this, and some extras don't know this, but you know how to do this, which is this formula here, all right? I'm sure you remember that we were trying to figure out dB, okay? And I'll go over this with you again on Thursday. But remember, it was the reference power, right? Reference power over the measured power. So our references, our radio says it puts out 100 watts because that's what they say in the manual. When I measure it at the antenna, it's only putting out 50 watts. How many dB is that? We would use this formula. we do the math first, and then we take the log of whatever this comes out to be, and then we multiply it by 10. No biggie, okay? Again, the ones you need to know are on the study sheet, so I need you to know 6 dB, 3 dB, 20 dB, and minus dB. It's on the study sheet, but I think it's pretty cool if you know how to figure this out, okay? Just to put the extras in their place, okay? So this is no biggie, and then we're going to talk about this -1 deal. This gives some people a little bit of trouble. No biggie at all, okay? I promise that we'll figure it out. I'll show you how to do this. And then we go into RMS power and peak envelope power and peak to peak. No biggie. Don't be afraid of it. I want you to just go through it as much as you can, and I'll be glad to go over it with you. Any questions on any of this stuff?
Hey, Joe, quick question about all those formulas that were in there. That's why I said that Chapter 4 was a beast. I understand that you showed us the maybe, what was it, 2 or a few of the equations. So are you trying to say that the rest of them, or the majority of them, will not be on the exam?
Yeah, so here's what I'm suggesting to you, okay? I want you to understand how they work, okay? I do want you to understand how they work and why they're there, okay? I don't necessarily want you to understand how to compute all of them. Quite frankly, if you go to hamstudy.org and take just Chapter 4, you can do just Chapter 4, Components and Circuits, and take that exam. There's only 22 questions in the pool that they can ask you, okay? After a while of getting them wrong, you'll figure out what the right answer is. So I don't want you to stress over it is what I'm saying. I do want you to understand how they work, and as certainly somebody who's taken one of my classes, I want you to understand if in a pinch you had to figure it out, you'd pull out the manual and you'd remember how we figured it out, right? But do I need you to know every single answer? No, I wouldn't worry about it so much, okay? Just out of repetition, if you go over hamstudy.org and you take just Chapter 4, Components and Circuits, you'll see that the same questions are asked over and over and over again, and sooner or later you just memorize them, okay? So I don't want people stressing out over it, okay? This is the toughest chapter that you're going to get. Don't stress over it. I'll explain how they work and why they work this way. If you want to do the actual math, fine. Then we'll do the math. You now know how to figure out resistors, capacitors, and inductors in series and in parallel circuits. I know you do because we did it together. And I'm going to send you a sheet to follow up on that. So all of them are kind of that way. All right? They're not really no harder than that. Does that answer your question?
Yeah, yes, it does, Joe. In other words, you're telling us with all these crazy formulas, if you don't want to memorize the formulas, then you have to memorize the 22 questions.
That's right. And you know what? They come really fast. I promise. I promise. Yeah, we'll go over them until they come out of your ear, and you'll see that after you get them wrong 5 or 6 times, you get them right. Okay?
Okay.
It's just the way it is, just by repetitious. I do want you to understand what they look like, and I want you to understand their purpose, okay? And in a pinch, yes, I expect you to whip out your calculator and figure this out. To be honest with you, I hold an extra class license. I'll get stuck. I'll go back and I'll try to figure it out, and sometimes I still get it wrong. I'm not going to lie. So I have to do it 2 or 3 times before I get it right. So please don't stress is what I want you to know. All right, any other questions? Bradlin says logs look scary, but they're basically awesome once you understand what it is. You're absolutely right, Bradlin. Yes, question.
Joe, I noticed that holding a novice ticket, that when I pass the technician exam, I will use a /KT. Why is it K instead of A, do you know?
So what license do you hold now?
I hold a novice license.
Oh, because you were grandfathered in. So yes.
That's right. Yes.
Yeah. That's the reason for the K, because you came from a novice class and not technical class. So you took it when CW. You had to take a CW portion of it.
I took a CW test. This is probably 25, 30 years ago.
You did better than me. Let me tell you. I didn't handle the CW until about 20 years later. Yeah, that's great.
Is that right?
That's awesome.
Yeah, I'm kind of looking forward to getting back into the CW portion of it.
It's very cool, and now with the new stuff that they have in the radios is so precise. So you were into it when they had tubes and stuff, right?
Yep, absolutely.
And they would drift all over the place, and wow.
And then the transistors came along, and I was going to school at the time and didn't have a lot of time to spend with it, and kind of got disenchanted with having to try to work with the semiconductors, which were brand new back then. That seemed like magic, and so I kind of lost it, and that's why I'm back at it now, to try to get back into it.
Well, so I don't know about the rest of the class, but I vote Bill to be our CW expert from now on, okay? Because in the old days, we had tube radios. Transistors didn't exist. And you can't just turn on a tube radio. It doesn't work that way, okay? I think all of these guys are all spoiled, Bill. So you'd have to turn it on. You'd have to wait for it to warm up, but not overheat, okay? It had to be at a certain, right? Otherwise, you tune in one frequency, and by the time it warmed up, you'd be completely someplace else, whatever the ambient temperature happened to be. And then it was hard to...
I built my first shortwave radio, Heathkit AR3.
Yeah. So Heathkit used to be like a Radio Shack on steroids, and they used to have all of these kits, and you would build them. You couldn't just go buy a radio. So, or you could, but most people wanted to build their own from Heathkit. Great company.
That's right.
Yeah, and you'd spend a month or two building the thing, and you had these tubes, and oh man, I remember those days.
It was fun.
Wow.
Yep.
Yeah. Well, Bill, no such problem now. So now you just turn it on, and it's all quadra locked in and quartz controlled and all sorts of cool stuff. Okay.
Right.
Any other questions?
My exam is Saturday, so looking forward to it.
Good luck. You know what? So you're going to go for the general?
Well, I got to start with the technician first, of course. But when I finish that, I've taken a couple of practice generals, and I've passed a few and failed a few. But I'm going to try it anyway. See what happens.
Yeah, try hamstudy.org, and then concentrate on this chapter, in Chapter 4, which should be the only problem you really have. Everything else, the rules of physics have not changed. So.
Yep. Cool.
Yeah, and then Karen. Wait a minute, I'm getting a lot of text. Something about bell bottoms. Somebody wrote something here. Hold on. Karen, the troublemaker in the group, writes, were those in the days of bell bottoms, jeans, and bad hair? Karen, you have no idea, Karen. No idea.
Actually, before that, Karen.
Yeah, I'm sorry, Bill. What were you saying?
I said, actually, before that.
Yeah, absolutely.
Before bell bottoms and bad hair.
Yeah, Karen, you don't want to know. As a matter of fact, we lived through it. We don't want to know. Okay, Bradlin said, can you take the technician and general exam at the same night? Absolutely, and that's what I suggest you do. Why? Because you only have to pay $15 once. So you take the technician, you ace it, because you were in my class, all right? So Bradlin, so you're going to ace it like everybody else has done, and then you're going to say, could I have the general exam, please? Then the examiner is going to look at you, look down from his glasses and say, are you sure, son? And you'll say, I'm not afraid. Okay. So, and
I don't think he'll say son in my case, but.
Yeah, well, yes, sir.
Yeah, when I took the test last week, actually it was the examiners who talked me into taking the general.
Yeah, there's two schools of thought, okay? In my club, the guy who heads the VE gets all bent out of shape. If you take the general exam and haven't studied for like, a month before. I think it's good experience just so you see what some of the questions are, okay? And yeah, okay, I don't expect you to pass it, and that's okay. I don't count that as a failure. I count that as it's a freebie. At least you see what it looks like, and you kind of get an idea of what they're going to ask you. So I don't see it. So yeah, the answer is yes. Yeah. And Anthony writes to me, "Hey Joe, what do you think of the Electrocraft kits? I think they're the best radios ever made on the planet Earth. Period. And they're pricey, and they are pricey. The kits are awesome. They're not really kits that really bolt together. Electrocraft is one of the finest radios I've ever had the pleasure of working with. I would never give up my KX3. I'd rather give up my dog. No, I wouldn't do that. I love my KX3. Any other questions?
Joe, quickie.
Sure.
The CME from the other day may show up as Northern Lights tonight if you've got view to the north.
Is that right?
Yeah.
Yeah. So CME, coronal mass ejection.
Yes.
So the sun got pissed off at somebody and try to, remind
Big
them
time.
who's boss. Yeah. And who the
Big
big guy
time.
is.
A 4 out of a 5, from what I understand.
No kidding. No kidding. Wow. That's serious. And that can knock out transmission, aircraft transmission, all sorts of stuff. So
They're also suggesting that it may knock out power grids in some locations.
yeah, it's pretty serious. It's pretty serious. The sun is still king. Any other questions? All right, guys, I'm going to send you. Who doesn't have the book? Do people not have the book? Anybody not have the manual?
This is Andy Eubanks. I haven't got the general yet.
Okay. I'm going to send it
Yeah, I haven't
out.
got it either.
All right. So here's what I'm going to do. I'm going to send you out a PDF, and I hope it gets through. Some people with small email accounts may not be able to get it. I'll know if it didn't get to you. I'm going to send you a PDF, which is only Chapter 4, okay, of the manual. I certainly want to go over it with you in detail, and it's worth having. So I'm going to send it to everybody along with another copy of the study sheet, and I'll send you the thing about how to compute reciprocals on your calculator. So you should get those 3 things from me this evening. If you still don't get it, I'll try to get it to you some other way, although I'm not sure exactly how I'm going to get it to you. But I'll get it to you one way or another, just so you have it. And that's it. All right, cool. And Karen says, I have Chapter 4 from a previous email. All right, I'm going to send it again anyway, just so I don't have to worry about who got it and who didn't. And the only one I can't seem to get it to is my buddy out in Wyoming, but I think he's got the manual, right? Somebody? Who's our friend out in Wyoming? Maybe not. Okay. Any other questions?
You could use a OneDrive or Dropbox or something like that, Jeff.
Yeah, that's an alternative too. Yeah, Dropbox. Let's see who gets it and who doesn't. Okay. So, and then if you need the only chapters I suggest you have the book for are 4 and 5. Let's concentrate on 4. Get through that. We got through 3 chapters tonight. We'll get through Chapter 4 next class, and then it's all downhill from there. Okay. So that's the hardest it's going to be. And please, please, please don't stress. Okay? Sounds good, Joe. All right, guys. Have a lovely evening. And I'll
Have a good night, Joe.
All right. Good night.
Good night, Joe.
All right, thanks, Joe.
Good night.